Alright, let's talk about geometry of covalent bonding. This is known as the VSEPR theory, and VSEPR stands for valence shell electron pair repulsion. So this is the acronym for this theory. Now this deals with electrons because covalent bonding is all about the valence electrons and how they bond and are shared with other atoms. So pairs of electrons are negatively charged. And due to this same charge, they repel each other because opposites attract and likes repel. And as a result, they want to be as far apart from one another as possible because they're the same charge. They don't want to be next to each other. Because of this, molecules take advantage of the 3D space that they have rather than the flat space we see them as when we draw the Lewis dot structures. So the molecular bonds will arrange themselves around the central atom so that the lone pairs are as far away as possible from each other. They have the greatest angle away from one another. And the way that we determine the number of domains in a molecule is by looking at the central atom. And we count how many atoms are bonded to the central atom or there may be some, there may be not, the number of lone pairs around the central atom. And here are some examples of what I mean. If we look over here at this molecule, we have 3 domains. Because here's a central atom, carbon, and we see that we have 1, 2, 3 atoms bonded to it. Now notice I didn't count this double bond as 2 domains because I'm not interested in the bonds. I'm interested in the atoms that are bonded to the central atom. So it doesn't matter if it's single or multiple bonds. It matters about the number of atoms bonded to the central one. So we have 3 here. And also notice I didn't count the lone pairs on an atom bonded to the carbon because I'm just interested on what's around this central one. So this is 3 atoms bonded to it and therefore 3 domains. Over here we have methane and there are 4 domains because we have 1, 2, 3, 4 atoms bonded to it and no lone pairs. So just 4 atoms around this central atom. And lastly over here we have ammonia, NH3. And this also has 4 domains, but it's different than the methane. We have 1, 2, 3 atoms bonded to it and 1 pair of lone electrons, lone pairs. So again, what's around the central atom? 3 atoms bonded and 1 lone pair. So let's talk about lone pairs. They take up a little more space than a bond between another atom. And this is because they are just connected to the central atom, so they balloon out a little bit. It's not being stretched, I guess you could say, between 2 atoms. It's just sitting on that one central atom and balloons out. And because of this, it has a greater repulsion between the lone pairs and the surrounding bonding pairs. And repulsion meaning they're repelling more between the lone pairs and the covalent bonds on the central atom. So the lone pairs take up a little bit more room and in a sense push the bonded pairs closer to one another in order to get the greatest angle from each other. And this in turn distorts the structure. So let me depict this for you because this may be a little confusing. On this side we have a tetrahedral. We have 4 domains, 4 bonded atoms, and they all are evenly spaced and have a 109.5 degrees between the bonds. Over here we also have 4 domains, but this is a bent shape, molecular shape. And we have a 105 degree angle between the bonds. And that's because these 2 sets of lone pairs are ballooning out and pushing these bonds further away, closer together, and reducing the angle between them. So here we have the VSEPR theory with our 5 molecular shape names. We're going to fill out the first row. So I'm going to minimize this and I'm going to go to Google and Google molecular geometry. Wikipedia is a good source for this. You can go to Wikipedia and scroll down to the VSEPR table, which has many more shapes than we are going to learn about today. So we are going to do the vent. Now, as you notice, there are 2 vents right here. And I want to do lone pairs. Okay, I want to do the 109.5 degree one. So I'm going to right click on this picture and copy the image. Then I will paste it and put it in here so I can just see it. Then I want to look back and figure out the number of atoms bonded to the central atom. And if we look here, there are 2 bonding electron pairs and 2 lone pairs. So we have 4 domains, and the bond angle is 109.5. So for homework, there's a Mathematica sheet, and I want you to fill in the remaining 4, just like we did.